Hello, today's video we're going to look at finding the derivative of several functions. And the first one we want to look at today is the function g of x equals -4. And recall our limit definition for finding the derivative is the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0. So to get started here, we want to find f prime of x and for this function we need to evaluate f of x plus delta x. So remember, that means we're going to take x plus delta x and substitute that in to our function for x. And the confusing part here may be is there's no x value. Well, that just simply means that no matter what our x value is, our y value is always a -4. So when we plug in x plus delta x, we're going to get out a -4. And if you notice now, it's minus f of x. Well, when I say f of x, this problem, or f of x in this case, is really g of x. So I guess technically out front here, instead of g prime, f prime, we should call this g prime of x. Well, our function here is simply -4. So that's minus -4, all divided by delta x. Now, once again, we can't substitute in 0 for delta x because we have delta x on the bottom. So we need to eliminate that somehow. Well, if we notice what's going to happen to the numerator, -4 minus the -4, that's going to go to 0, but that's still divided by delta x. Well, can we still use direct substitution? Well, the answer is no, because we would have 0 divided by 0, which is undefined. However, we can simplify this. 0 divided by delta x, we know, is going to be 0. Once we do that, we can take the limit of 0, which is a constant function, which is going to be simply 0. So therefore, g prime is 0. So therefore, the slope is 0. Now, if you notice, this is a constant term, so that means our slope, or the rate of change, is always 0. And you're thinking, well, we knew that because if you look at the original function, the graph simply says go down to -4, which means we would have a horizontal straight line, which we know the graph, or the slope rather, of any horizontal line is going to be 0. So really for this example, we didn't have to go through this limit process to find the derivative because we already know the slope is going to be 0. All right, let's look at another example. We want to find the derivative of the function f of x equals 3x plus 2. And once again, we know that our formula and after you write this formula down enough times, you will definitely memorize this. So here's our derivative formula. And if we want to find f prime of x, we're going to take the limit as delta x approaches 0. And now we need to evaluate the function here at x plus delta x. So recall, that means we're going to plug x plus delta x in for x. So we would have 3 times x plus delta x plus 2. And then we're going to subtract away the function itself. So it's minus, and notice I'm going to put a bracket because we're subtracting everything, the entire function 3x plus 2 divided by delta x. And make sure here that you include the brackets at this top, 3x plus 2, because this negative will have to be distributed to everything. So just like here we have to distribute the 3 on top, we're going to get 3x plus 3 delta x plus 2, and now we distribute the negative sign and we get a negative 3x minus 2 over delta x. Now, can we use direct substitution? And the answer is no, because once again, we still have delta x on the bottom. Recall the main goal is to get this delta x to cancel out. So we need to continue to simplify the numerator. And if you look closely, the 3x, negative 3x cancels, positive 2, negative 2 cancels, and we're left with a 3 delta x on top and a delta x on the bottom. And notice your delta x will cancel. So then we are able to take the limit of 3. Once again, we end up with a constant, and we simply know the limit there is going to be 3. So therefore, that is our derivative. Notice again, our derivative is a constant. So that simply means the rate of change, or the slope, is going to be the same throughout the entire function. And once again, hopefully you've noticed this. If not, if you look at the function is 3x plus 2. And if we were to graph this function, we know it's going to be a straight line with a y-intercept of 2, a slope of 3, so we could go up 3 and over 1. And if we look here, the slope of this line is going to be 3 over 1. And again, because it's a straight line, this slope, no matter what 2 points you pick, the slope, the rise over run, is always going to be 3. Once again, this is just to take you through the process. If you were truly given this problem, you really wouldn't have to go through this whole process, because we know right here, this 3 is going to be our slope, because y equals mx plus b.